Jumping into part 121 of someone's personal programming notes, uh, it feels exactly like opening this massive epic fantasy novel right at the climax of the third book.
Yeah, no gentle introduction at all.
Exactly. You bypass all the careful world building, the slow exposition, and suddenly you are just dropped directly into the middle of the action. The swords are clashing, the magic is flying, and you have to get your bearings incredibly quickly.
It's a real baptism by fire, honestly. You're looking around the landscape trying to figure out who the main characters are, what the stakes are, and, why certain decisions are being made with such extreme urgency.
Right. And we are examining a truly fascinating developer's journal entry today. It was published today, actually, April 28, 2026, by a developer named Ang.
Oh, and the title alone tells you the depth of the journey we are on today.
Yeah, it's called Notes on Haskell Programming, Part 121, Generating PDFs with Typst and Pandoc.
Part 121. I mean, the sheer dedication there is amazing.
It really is. And our mission for this deep dive is not to sit here and dryly read off lines of code syntax.
Please no.
Right. What we are really exploring is the very human experience buried inside these technical notes. We are looking at the reality of learning a notoriously difficult programming language, like Haskell.
Which is famously unforgiving.
Totally. We want to understand how we, as humans, overcome incredibly dense information. And we'll look at the elegant and sometimes really frustrating ways developers bridge the gap between abstract, purely logical systems and tangible, real-world outputs.
Right, and in this specific case, that output is just a simple PDF document.
Exactly. So to set the scene, Ang is in the middle of a very specific practical task, right?
Yeah, they are trying to add this placeholder function to their project to generate an ebook in PDF format.
And to achieve this, they're using the Typst formatting engine.
Right, routed through Pandoc. And what makes this entry so compelling right from the jump is that Ang notes they've actually achieved this exact thing before.
Oh, really?
Yeah, quite successfully, but in a completely different environment. They originally built this in a Python console app called TXT2 book, I think.
Okay, so Ang already knows the underlying concept here.
Exactly. They already understand the mechanics of taking a text file and turning it into a formatted ebook because they literally built it in Python.
So the challenge isn't the task itself. It's translating that established knowledge into the highly rigid mathematical world of Haskell.
Yeah, taking what you know and trying to speak a brand new, highly complex language.
And before Ang can even type out the solution, they hit a massive wall.
A very familiar wall.
Oh, yeah. It is a wall anyone who has ever tried to pick up a complex new tool can deeply relate to. The documentation.
Oh, man. The docs.
Yeah. Ang points out almost immediately that when it comes to reference materials, Haskell, and honestly, most other tech stacks they've used, just completely pales in comparison to a language called Elixir.
Yeah, Ang specifically calls Elixir the gold standard for documentation tooling.
Right, praising a tool called Xdoc.
Because it just works so well for the learner. Let's unpack the reality of reading Haskell's documentation because Ang's frustration in this entry is palpable.
I could feel it through the screen.
Right. The API docs for most Haskell libraries lack basic examples. The writing style is dense and deeply theoretical.
Reading these docs sounds like trying to build a massive, intricate piece of IKEA furniture. But the manual is just one solid, unbroken paragraph of text.
Oh, that's a perfect way to put it.
Yeah, just text describing the tensile strength of the screws with absolutely no pictures of the actual furniture.
And Elixir's Xdoc, by contrast, is like having a perfectly paced, step-by-step YouTube tutorial playing right next to you.
Showing you exactly where each piece goes before explaining the physics behind why the shelf holds weight.
Exactly. And this distinction highlights a fundamental flaw in how information is often presented to learners in highly technical fields.
Because it's written by experts, right?
Yeah. And when you provide only a dense paragraph of theoretical text, you force the reader into extreme cognitive overload.
We have to do all the heavy lifting in their head.
Right. They have to parse the theory, imagine the practical application entirely in their head, and then attempt the execution all at once. It's too much.
Whereas Elixir's approach lowers that initial barrier. It provides clear, executable examples.
It lets the learner see the tool functioning in the real world before they are required to understand the abstract theory of why it functions.
But here's where I want to push back a little bit on Ang's methodology.
Oh, okay.
Because the documentation is so impenetrable. Ang's solution isn't to just sit down and study the manual until it finally clicks.
Right, they take a shortcut.
Yeah, Ang explicitly states they task an AI to bootstrap a small working snippet of code.
Yep, an AI copilot.
And then, They take that AI-generated foundation and tweak it line by line. And I just have to ask, isn't that just a crutch?
That's a common reaction, yeah.
I mean, if you were relying on an AI to write the initial code because the manual was too difficult, you aren't really learning the language. You're just learning how to prompt a machine to do the hard work for you.
I get that critique, I really do. But if we look at the mechanics of adult learning, I would argue it functions more as a modern translation layer than a crutch.
A translation layer.
Yeah. Because, like we said, dense documentation is almost universally written by experts for other experts.
Right.
It assumes a massive amount of prior context, a shared vocabulary that a learner like Aang just hasn't acquired yet.
So the AI fills in that gap.
Exactly. When Aang uses an AI to generate that initial working snippet, the AI provides the what. It outputs a functional, completed puzzle.
But having a completed puzzle doesn't mean you know how the pieces were cut.
Exactly, which is why Aang's next step is the crucial one. Aang isn't just copying and pasting blindly into the code base.
Right. They said they tweak it line by line.
Yes, they use that snippet as a foundation. That is the human reverse engineering, the why. You start with a working model, and you start breaking it on purpose.
Oh, I see. You change a variable to see what error the compiler throws.
Right, or you comment out a line to see which part of the PDF generation fails.
So you are using the AI to bypass the friction of poorly designed documentation.
Yes, allowing you to learn through experimentation rather than passive reading.
Okay, that makes a lot of sense.
Mhm.
You aren't asking the AI to build the whole house. You are asking it to show you a finished brick wall so you can poke at the mortar and figure out how it holds together.
That's exactly it. It accelerates the time to understanding. And once Aang reverse engineers that working snippet, the next challenge is actually integrating that code into the larger project.
Which is never as simple as it sounds.
No, never. And this introduces a surprisingly philosophical debate among developers about how to organize a workspace.
So the imports?
Yes, Aang refers to it as the eternal question: too qualified or not too qualified?
This part was fascinating. It's all about how developers declare the external tools they are bringing into their code.
Right, because when you write a program, you almost never write everything from scratch.
You borrow tools, functions, and data types from other modules.
Exactly. And in this case, Aang is pulling in tools from external libraries to handle the PDF generation.
But Aang admits to making a bit of a mistake here, right?
Yeah, they overlooked explicitly listing all the imported functions from a module called Typst.Pandoc.
And because they didn't list them out, Aang realized later they had absolutely no idea what specific tools had actually been dumped into their workspace.
Right. To understand the trap Aang fell into, we really need to look at the three primary ways you can import tools into a Haskell environment.
Okay, lay them out for me.
First, there is the unqualified import. This grabs every single tool available in an external module and brings it into your current file.
Just grabs everything.
Everything. Second, there is the explicit list, where you define exactly which 3 or 4 tools you want.
Makes sense.
And finally, there are qualified imports.
Visualizing this helped me grasp why this is such a massive debate. Using an unqualified import feels like taking a massive toolbox and dumping every single tool you own directly onto your workbench.
Yes, just a massive pile of metal.
And in the moment, it is incredibly fast. You don't have to think about where anything is. You just reach out and grab.
It's super convenient right then and there.
But eventually, the workbench gets so cluttered that you reach without looking and you grab a metal hammer when you actually meant to grab a rubber mallet, simply because they're sitting right next to each other in an unorganized pile.
And that workbench analogy perfectly captures the concept of namespace clashes in code.
Right.
Let's say you use unqualified imports to dump the tools from a map module and a list module onto your bench.
Okay.
Both of those modules happen to contain a tool called lookup.
Oh, I see where this is going.
Yeah. When you write the word lookup in your code later on, the compiler looks at the messy pile on the bench, sees 2 identical tools with the same exact name, and completely panics.
Because it doesn't know which one you want.
Exactly. It throws an error because it has no idea if you meant the map lookup or the list lookup.
And this is where the labeled drawers come in. Aang notes that their current method is mostly using the unqualified approach, but with one major exception.
Right, the prelude module.
Yeah, they use qualified imports specifically to avoid those namespace clashes with Prelude, which is Haskell's default toolkit.
The qualified import essentially forces you to keep the tool in a labeled drawer.
So how does that look in the code?
Well, if you import the map module qualified, you can't just type lookup anymore. You have to type map.lookup.
Oh, so you were explicitly telling the compiler, go into the map drawer and get me the lookup tool.
Exactly. It completely eliminates the ambiguity.
But Ang also mentions what they've gathered is the hybrid best practice. And this approach shows a really elegant compromise.
It really is the sweet spot.
Ang notes the ideal way is to import the types unqualified. So you write import data.map and then map in parentheses.
Right, which keeps the type signatures, the blueprints of your code, looking incredibly clean and readable.
But for the actual functions, the actions you are performing, you import those qualified. You write import qualified data.map as M.
Yeah.
That way, when you want to use the tool, you just type m.lookup or m.insert.
You're putting a tiny shorthand label, that m dot, right on the tool before you use it.
It's brilliant.
It balances cognitive load perfectly. Your foundational blueprints remain uncluttered, but every time you take a concrete action, the origin of that action is explicitly clear.
So when you revisit this code 6 months from now, you don't have to guess where a function came from. You've left breadcrumbs for yourself.
Exactly. Future you will be very thankful. But, organizing the internal workspace is crucial, but all of that organization is just prep work.
Right. The entire goal of this project is to actually create a PDF.
And a PDF isn't pure internal logic. It is a physical file that has to exist on a hard drive.
So to create it, Ang's internal program has to cross a boundary and interact with the chaotic outside world.
Yes. And Ang notes they're using a builder pattern to generate the sample document.
I like this part. The builder pattern is a great mental model. Ang compares it to writing HTML to construct a full web page.
Right. Instead of writing one massive block of text, you programmatically assemble the document piece by piece.
Defining a header, attaching a paragraph, inserting a table.
You build the abstract structure of the document internally first.
But to actually render that structure into a PDF, Ang's code needs the Typst executable installed on the actual computer system.
Yes. The program has to reach outside of itself, ask the operating system to run a completely separate program, and just hope it works.
And in Haskell, you can't just casually make that request anywhere in your code.
No, absolutely not.
Ang points out this action must happen inside something called runio, using the PandocIO monad.
Ah, the M word.
Yeah, I have to be honest, the moment I read the word monad, my brain wanted to just shut down.
That is a very common reaction.
Haskell's reputation for being deeply intimidating usually centers around this exact concept, what actually is PandocIO.
Well, the intimidation is incredibly common, but we can demystify it by looking at why Haskell requires it in the first place.
Okay, why?
Haskell is fundamentally obsessed with purity. A cure function is predictable. If you give it an input of A, it will always, without fail, return an output of B.
It doesn't rely on anything outside of itself.
Right. But the real world is inherently impure. If your code tries to read a file, that file might have been deleted by the user.
Well, the hard drive might be full.
Exactly.
Yeah.
The Typst executable might crash. Haskell refuses to let that real-world unpredictability contaminate its pure logic.
So the standard I/O monad, is that basically a delivery driver?
A delivery driver.
Yeah, like it's a designated worker whose only job is to leave the safe, predictable warehouse, drive out into the messy real world, drop off the data, and report back on whether the delivery was successful or if, the bridge was out.
Oh, that is a highly accurate way to visualize the standard I/O monad. It isolates the side effects.
Right.
But Ang isn't just using standard I/O. Ang is dealing with Pandoc, which is an immensely complex document conversion system with its own vast array of internal states, warnings, and highly specific failure modes.
So if the standard I/O monad is a standard delivery driver, PandocIO feels like a heavily armored truck.
Yes. An armored truck designed specifically for transporting highly volatile documents.
Okay, let's blow it.
If a standard delivery driver hits a pothole, they might just report a generic delivery failed error. But PandocIO is a specialized wrapper. It knows exactly how Pandoc behaves.
So it can give better feedback.
Exactly. If the Typst executable fails to render a specific font, PandocIO traps that specific error, preserves the internal state of the document up to that point, and safely returns that detailed information back to the pure Haskell code.
Without crashing the entire system.
Right. It operates within a strict set of protocols tailored to Pandoc's unique vulnerabilities.
So we're quarantining the unpredictable parts of the universe inside this armored truck. So the pristine mathematical logic of the application stays perfectly safe.
Beautifully said.
But sending a specialized armored truck out into the world requires a massive amount of instruction.
Oh, definitely.
You have to configure the routes, the security protocols, the emergency contacts. If you had to fill out that entire configuration manifest manually every single time you wanted to run a simple document conversion, it would be exhausting.
Which brings us to one of the most elegant time-saving concepts in Ang's entire journal entry.
Yes.
Instead of manually filling out that massive configuration form, Haskell offers a powerful shorthand, a tiny word called def, D-E-F.
And Ang immediately issues a warning to the reader about this word.
They do, because it's tricky.
The warning caught my eye immediately. If you are coming from Python or Elixir, def is the keyword you use to announce you are defining a brand new function. It literally means define.
Right, but Ang emphasizes that in Haskell, it serves a completely different purpose. It comes from a module called Data.Default.
So what does it actually do?
In Haskell, def is a way to call upon default values for complex data structures, and it utilizes Haskell's powerful type inference to do this polymorphically.
Okay, polymorphically is a heavy term.
It is, yeah.
Let me see if I can ground this in what Ang is actually writing. Ang uses the command write Typst def sample doc.
Right.
The system needs to know all the complex configuration options for writing this Typst document, but instead of providing them, Ang just types def.
Yes.
Are you saying the Haskell compiler looks at the function write Typst, recognizes that it requires a massive configuration blueprint called writer options, and automatically assumes def means give me the standard default version of writer options?
The compiler does exactly that.
Wow.
It looks at the surrounding context, sees the gap that needs to be filled, and injects the correct default data structure automatically.
It's like walking into your favorite regular diner, sitting down at the counter and just telling the waiter, I'll have the usual.
I love that.
The waiter is the Haskell compiler. You don't have to specify that you want 2 eggs scrambled, whole wheat toast, and black coffee. The waiter looks at you, looks at the breakfast menu, and automatically infers what the usual means in this specific context.
The diner analogy captures the convenience perfectly, but the true power of def reveals itself when you need to make a slight modification.
Okay, how so?
Well, writer options isn't just a plate of eggs. It is a massive data structure containing dozens of intricate fields. Margin sizes, font families, metadata tags, table of contents depth.
Right.
If you wanted to change just one of those settings, say the template, you would normally have to write out the entire structure from scratch, passing along the default values for the other 30 fields manually.
Which would bring us right back to the exhaustion of the IKEA manual.
Precisely. But Ang demonstrates how you bypass that entirely. They show a future commit where they write let ops equals def, and then in curly braces, writer template equals just template.
Oh, so the syntax is literally saying, I'll have the usual, but swap the fries for a side salad.
Exactly. You are utilizing Haskell's record update syntax. You start with the massive intelligent foundation of def, the usual, and you only explicitly declare the single field you want to override.
And the compiler handles the rest.
Compiler handles all the boilerplate for the rest of the structure. It is a profound respect for the programmer's mental energy. You are only required to type out the things that actually matter to the specific change you're trying to make.
That is so incredibly efficient. When we step back and look at the whole picture, the journey through part 121 of Ang's journal is remarkable.
It really covers a lot of ground.
We started with the universal frustration of staring down impenetrable, dense documentation, the IKEA manual with no pictures.
Right.
We explored how using an AI copilot as a translation layer can give us the foundational what, so we can experiment and learn the why.
Tweak it line by line.
Exactly. Then we moved into the philosophy of organizing our workspace, learning to explicitly label our functions with qualified imports so we don't grab the wrong tool during a namespace clash.
Keep everything in its drawer.
Yeah. We learned how to protect our internal logic from real-world chaos by wrapping our external actions in the PandocIO armored truck.
To keep the pure functions pure.
And finally, we saw how to eliminate exhausting boilerplate by leaning on polymorphic defaults, just asking the compiler for the usual so we can focus our energy on what we actually want to change.
It's a great workflow.
It is. Whether you are deep in the trenches of a Haskell code base, organizing a massive physical project at work, or just trying to learn a complex new skill, the underlying principles here are universally applicable.
Absolutely.
Organize your tools so future you knows where to find them. Protect your delicate internal processes from external chaos, and set up smart, reliable default so you aren't wasting your time repeating the same foundational work every single day.
That's the real takeaway here.
Thank you so much for joining us on this deep dive. Keep exploring your own workflows, keep pushing through the dense manuals, and keep looking for your own gold standards. Stay curious.
You know, the strategies we've discussed today are all about managing the overwhelming complexity of modern systems. But there is a lingering thought that Eng's reliance on AI provokes for me.
Oh, what's that?
Well, if the documentation for our most critical infrastructure is becoming so dense, so intricate, and so deeply layered that dedicated developers feel compelled to rely on AI just to generate the initial understandable snippets, it raises a fundamental question about the future of human learning and technology.
That's a good point.
If the machine is the only entity with the bandwidth to quickly parse the manual, will the programming languages of the future even need to be readable by humans?
Wow.
Or will code eventually become a purely machine-to-machine language, something so dense and abstract we don't even attempt to read it, while humans simply become the high-level architects of ideas, speaking exclusively in plain language to our AI co-pilots? It suggests a future where the role of the developer shifts entirely from a writer of syntax to a director of intent.